Aishwarya, can you walk through the steps again? Tell why it is, how we get close to pi by 3. Tell the details also. Tell the details.
Yes.
Okay. Yes, Aishwarya, go ahead.
Yes, sir. First we have 1 by 100. In denominator we have 3, sir. And in numerator 100, 101 and 201. And 100 get cancelled. So there we get 1, sir. And 101 divided by 100 we get 1.01, sir. And 201 divided by 100 2.0 2.01, sir. So 2.01 is nearer to 2 and 1.01 is nearer to 1, sir. And in the numerator we have 1, sir. So 1 plus 1, 2, sir. 2 plus 0.01 is nearer to 1, no, sir. So we get 3, sir. And 2.01 is nearer to 2. And we there we got 1 plus 1 plus 1 plus 2, 5, sir. And the denominator we have 3, sir. So 5 by 2.
One second. Tell me again after the 1.01 and 2.01. So you have 300s and you have in the numerator, the 300s cancel, the 100 cancels with one of the 100. The 101 becomes 1.01. The 201 becomes 2.01. Tell me after this point. After this point, what did you say? After I highlighted this point, what did you say after that?
So when we cancel 100 and 100, there we get 1, sir. Yes. So in 1 by 6 we have 1, sir, numerator, and 100 and 100 get cancelled, 1, sir. So 1 plus 1, 2, sir. And 0.01 is nearer to 1. There we get 1, sir.
Where is the so we have pi into 1 by 6 into 1.01 into 2.01. So where is the plus? Which is the 0.01? What is the 0.01 you're talking about? Aishwarya?
Yes, sir.
Where is the 0.01 you are talking about? You said, did you say 0.01 or 1.01?
1.01, sir.
No 0.01, right?
Sir.
Is there any 0.01 anywhere?
No, sir.
No, sir.
Okay. Yeah, so just continue, Aishwarya. Just continue from the point of where you have pi into 1 by 6 into 1.01 into 2.01. Just continue from there.
Sir, I think that there is a plus and 100. When 100 get cancelled, I added the 1 by 6 plus 1, sir. So there I get 2, sir. And 0.01 is nearer to 1, sir. And I added 2 plus 1, 3, sir. And 2.01 is nearer to 2, no, sir. So I added 3 plus 2, 5, sir. So I misunderstood that, sir. Sorry.
But where is the plus? There is no plus here. Is there a plus?
No,
this is multiply, right? Yeah. So why is there a plus? See, remember what we are starting with. We are starting with pi times 1 by 100 cubed times this 1 squared plus 2 squared plus so on and so forth. Okay, so we get pi times 1 by 100 cubed times 1/6. And we're putting the formula. So we get 100 times 100 plus 1 times 2 times 100 plus 1. So it's pi into 1 by 100 cubed times 1/6 times 100 times 101 times 201. Okay, which is pi times 1/6 into 1.01 into 2.01. So it's all, now it is all multiplied. There is no plus. Correct, Aishwarya?
Yes, sir.
So can you now repeat? Now can you correct it without the plus? Okay, let's go to another person. Samiksha Chorlekar. Can you unmute?
So,
yeah. Can you repeat? Can you walk through the steps in detail?
yes, sir. So we have with according to formula we have pi into 1 upon 100 square cube into 1 by 6 into 100 into 101 into 201, sir. So we'll get pi into 1 by 6 into 101 divided by 100 and 200 into 201 upon 100. So after simplifying, sir, we'll get pi into 1 upon 6 into 1.01 into 2.01. So, sir, 1.01 is nearer to 1 and 2.01 is nearer to 2. So, we have in the numerator now pi into 1 into 0.01 is nearer to 1. So, it is 1 and 2.01 is nearer to 2. So, it is 2. So, sir, we will get in the numerator 2, sir, and in denominator will be having 6. When we simplify it, then we'll get 1 upon 3, sir, and pi into 1 will get pi and denominator will be 3, sir. So it is closer to pi upon 3.
Yes, good. Thanks. That's correct. That's fully correct. Okay. So we got little bit more than pi over 3. We approximately made 2.01 to be 2 and approximately made 1.01 to be 1. Now, can you tell me why we got slightly more than pi by 3? Samiksha?
Sir, because there is 1.01, so 0, 1 we have removed and only we have taken 1, no? So we'll get approximately more than pi upon 3.
Yeah. But why is it when we are trying to get the volume of the cone, the actual volume of the cone should have been pi by 3, right? Because the actual volume of the cone is 1/3 pi r squared h. And r is 1 here, h is also 1. So it should be 1/3 pi. Why are we getting slightly more than pi by 3?
So can
Yeah, who spoke just now?
So Mahalakshmi.
Okay, Mahalakshmi, go ahead.
So here we taken some cylinders, sir. There is an extra part in this, sir.
Exactly, yeah. Look at this figure. Okay, look at this figure. Remember that even in the triangle case, there is this extra steps here. The steps. So even in the triangle case, when we were adding up these areas, we were getting this additional area of the steps. And now in the cone, same thing is happening. We are rotating this approximate triangle around this axis DC. And we are getting this extra volume because we are rotating this part is slightly bigger than the cone. The steps, when you rotate, you get slightly more part. Okay, Samiksha, do you understand why it is more, slightly more?
Yes, sir.
Yeah, we are getting extra because of the steps. Now we are getting approximate value of the cone. Because why? Because we divide into 100 parts and those 100 parts giving steps. Now to make the volume of the sum of the cylinders to be closer to the volume of the cone, do we have to take more number of columns or less number of columns? Do we have to go from 100 to more and more, like million column, 100 to 1000 to million, or do we have to make it less? Which one of those two? What should I do to make it more and more correct, more closer to the volume of the cone? I should what to the 100? Instead of 100, I should take what? Should I take more value, bigger number, or smaller number? Samiksha, what should I do to the? I took 100, right? We divide to 100 parts and I got the steps. And I was
Yes,
getting
sir.
slightly more volume of the cone. So what should I do? Instead of 100, what should I do? Should I take much more or what should I do?
So less.
Should I take less, divide the thing into fewer parts? So if I divide the square into fewer parts, will I get more near to the, will the steps become more near to the, will this cylinder and the volume of that become nearer to the volume of the cone, or more different from the volume of the cone? Remember the area of the triangle. For getting the area of the triangle, we were dividing this into n parts. Okay. So the n, if we take some number of steps, if we take 10 steps, if we take 10 columns, then I will get this extra over the area of the triangle. And if I take 1000, then I will get very small steps. In which case is it closer to the area of the triangle? Is it when it is 1000 or when it is 100? So as I go from 100 to 1000 to million, will it get closer to the area of the triangle, or will it get farther from the area of the triangle? Samiksha?
So closer.
Closer in which case? When you increase n or when you decrease n? Which one?
So when we increase n.
Yes, yes. Okay. So we have to go for more and more. You have to go 100 to 1000 to million, and you have to make very big number. Then it gets closer and closer. Okay, is that clear? So we have to make that n. Right now we put n equal to 100. Instead of n equal to 100, we have to put n equal to million or more and more big number. So now, Samiksha, tell me, in this calculation that we did, okay, here in this calculation, we were taking 100, n equal to 100, right? And with n equal to 100, we were getting this 2.01 and 1.01 here. Now, instead of n equal to 100, if I take n to be more big, like million, will that what will happen to the 2.01 and 1.01?
So it will be 1.00001.
Yes, and the 2.01
And
will happen to what?
to 2.00001, sir.
Yes, correct. Okay, so the important thing to note is that when you go from n equal to 100 to a million, everything remains the same except that 1.01 becomes 1.00001 and 2.01 becomes 2.001. Now, what happens instead of million, you make it billion? Then what will happen?
So again zeros will increase.
Yes, yes. Okay. So the important thing to note is that in this line here, okay, this line here, okay. So this line here, this, as you make the n larger and larger, this 1.01 will become very, instead of 1.01, it will become 1.0000001. So it become like, in million, it will become like after the 6th decimal place. In billion, it will become the 9th decimal place. Same thing for 2.01. So as you make the n larger and larger, the volume that you of the sum of the volume of the cylinders that you got this way will become closer and closer to the volume of the cone. Okay, and then when you make n close to infinity, like you cannot make it actually infinity, but let's say you make it very close to infinity, like make it billion, like make it like 10 to the power 100. Then that 1.01 will become 1.00 zeros and then 1, or 2.100 zeros and 1. And that is actually more close to the volume of the cone. Okay. So let me just show the calculation. What happens with n? Okay. So in general, the formula will become so for n, formula is sum of volume of cylinders. Okay, so what is general formula for n columns? So earlier we had pi into 1 by 100 cubed, okay, into 1/6 into 100 into 100 plus 1 100 plus 1 times 2 times 100 plus 1. Now, can someone tell me the formula for with n? It become pi into
1 by n whole cube into 1 by 6 into n bracket n plus 1 2 n plus 1.
yes, correct. Pi into 1 by 100 on cube into 1 by 6, okay, into n plus 1 into 2n plus 1. Yeah, now we are making n very big. We are making n like billion, quadrillion, like very big numbers. Okay. Again, let's try to do the cancelling. Okay. So what will happen because of the cancelling? So we have to have 3 n's in the denominator, and we have an n here, and we have an n plus 1 here, and 2n plus 1 here. Now tell me what will happen here after cancelling. N will cancel with n. What will happen to n plus 1 by n? So remember, when n was 100, this was 101 by 100. So we're getting 1.01. Correct? So tell me, how will you say? How will you do argue approximately that this is very close to 1 and this is very close to 2 after the cancellation? Think about the 100 case, okay? N plus 1 was 101. 101 divided by 100, so that became 1.01. Now, when you make n bigger and bigger, what will happen? Who wants to say? Anyone? Anyone wants to take? I can help that person while the person is attempting. Someone raise their hand so that I can talk specifically to one person and walk through the thing. Who wants to go? Who wants to volunteer?
So I think that n plus 1 we should divide by n. So
Yes, correct.
n get cancel and 1 will be remaining.
Yeah. Okay, let's go through slowly. Okay. So the first n will get cancelled with n. The n plus 1 by n. Let's see what will happen to that. Okay. So you will get n plus 1 by n here. Okay. And then 2n plus 1 by n. Okay. Now tell me, so when n was 100, this was 101 divided by n. Okay, which is 1.01. How should I write this so that this is very close to 1? It is clear that this is close to 1. How should I write n plus 1 divided by n? What is n plus 1 divided by n? Why is it very close to 1? What is n plus 1 divided by n? Samiksha? Why is it very close to 1 for large n?
So n and n gets cancelled, so we get 1.
Yeah, and then but we have n plus 1 by n, right? We don't have n by n.
Can I?
What do we do about the?
So 1 plus 1 by n.
Yes, correct. Okay, so this is n plus 1 by n is 1 plus 1 by n. And what happens to 1 plus 1 by n as we increase n? So when n was 100, that 1 by n was 0.01, and that's why we're getting 1.01. Now, as n becomes million or billion or quadrillion, what happens to it? That 1 by n becomes tinier and tinier, smaller and smaller. It becomes more and more negligible. So earlier, when we were removing the 0.01, we were removing something which is not fully negligible. But when we make n million or a billion or a quadrillion or 10 to the power, like very large number, then it becomes very, very small. It becomes almost negligible. Okay. Now, what happens to this 2 times n plus 1 divided by n? How should I write this so that it is very close to, it's clear, very close to 2? What should I write for 2 times n plus 1 by n?
So n plus 1 by n.
Wait, 2 times n plus 1 divided by n. What is that? How will you write it? So remember, when n was 100, we were getting 201 divided by 100, which is 2.01. And for large n, how should I write this? 2n plus 1 divided by n.
2n by n plus 1 by n.
Yes, correct. And then if you simplify that, what will you get?
2 plus 1 by n, sir.
Yes, correct. Okay. So this will become 2 plus 1 by n. Now look at this formula. Now is it clear why this thing is becoming for large n, why this is becoming very close to 1 and this is becoming very close to 2? Is it clear? When we took n equal to 100, this was extra 0.01. When we took, this was extra 0.01 in front in addition to the 2. But if we make n equal to million, it will become only like 1 over millionth. When we take billion, then we get 1 over billionth. So that extra thing that you're adding to 1 or adding to 2 becomes very small. And the more larger you make n, the better this approximation becomes to the volume of the cone. The closer it gets to the volume of the cone. So when we make n larger and larger and larger and larger, very large, this will become very close to, what will become very close to? It's closer and closer to what? What does this become? Pi into? Yeah. What can I write instead of this 1 plus 1 by n and 2 plus 1 into 1 plus 1 by n and 2 plus 1 by n? What can I write? For very large n, as I make larger by n. Yes, I can just write it as
3 by n.
Sorry, repeat that again. Come again.
2 by n.
Okay, just who said? Who can you raise the hand? Whoever spoke? Madhumita. Yeah. What did you? Can you repeat what you said?
Pi into 1 by 6 into 2 by n into 3 by n.
Okay, how did you get 2 by n into 3 by n? So look at this. We have pi into 1 by 6 into 1 plus 1 over n. See, oh, okay. Wait. Do you see the brackets? Which takes precedence? So what is this? What is this thing? Can you tell me why? Is this 2 by n?
Oh, sir.
Where is the which will apply first? The division will apply first, or the plus will apply first?
Division, sir.
Yes. Which one? Sorry, who said plus? Okay, Madhumata, what is this? Is this first taking one, first applying the 1 over n, then adding 1 to it, or is it first doing 1 plus 1 and then whole thing divided by n? Which one is this?
So first we have to divide.
Yeah, first you have to divide. Okay, remember I had n plus 1 within brackets here. There is n plus 1 within brackets and then divided by n. Okay, and then I wrote that as, so let's just go clearly in the next slide. Okay, let me show it you clearly. So if I take n plus 1 and I divide by n, it is equal to, I have to first, I can take the n into both things, right? So I'll get n divided by n plus 1 divided by n. Okay, here the division is happening first and then the plus is happening, which is 1 plus 1 divided by n. Okay, so this 1 divided by n, the division happens first and then the plus happens. So go ahead, Madhumita. What is this now? Is this, should I add the 1 plus 1 or should I do the division plus? Now, can you continue from there?
So we should divide first.
Yes. So now tell me, as n becomes larger and larger, very large, billion, trillion, like that, what happens to this 1 plus 1 over n? Gets closer and closer to? What is 1 plus 1 over n when n is 100? When n is 100, what is 1 plus 1 over n, Madhumita?
101 divided by 100.
Yeah, how much is that?
1.01. 1.01, sir.
Yeah. Now, when I make n equal to million, then what is 1 plus 1 over million?
1.0001.
Yeah. Now, when I make n like very large, very big, think of the biggest, very big number. Think of 10 to the power 100. Okay. 1 followed by 100 zeros. Then what is 1 plus 1 over n? How many zeros after the 1? 1 point? 99 zeros and then 1. So this, as you make n larger and larger, 1 plus 1 over n becomes how much? Very close to? It becomes close to what?
1, sir. 1, sir.
Yes. So I can just write this as 1. Then this as the second one. What about 2 plus 1 over n? What does that become close to? What is 2 plus 1 over 100? What is 2 plus 1 over a million? As you make n bigger and bigger, what does it happen? Close to? 1 plus 1 over n was becoming close to 1. 2 plus 1 over n will become close to?
2, sir. 2, sir.
Yes.
2, sir.
Yes. So as you make the number of cylinders more and more, this will become very close to pi into 1 by 6 and 2, which is exactly pi by 3. So did everyone understand how we got the volume of the cone? By taking very small cylinders. You divide up the cone into very small cylinders and you get 1 squared plus 2 squared plus 3 squared, like that till n squared. By substituting the formula for 1 squared plus 2 squared till n squared, we got pi into 1 by n cubed into 1/6 into n plus 1 into 2n plus 1. Okay, and we put this because this is the formula for 1 squared plus 2 squared plus 3 squared till n squared. And then when we kept on simplifying, and we saw that it is pi into 1 by 6 into 1 plus 1 over n. Okay, and into 2 plus 1 over n. This 1 over n, this 1 plus 1 over n, if n gets larger and larger, it will become like very, very close to 1. It will become 1.0. If n is 100, it is 1.01. If n is in million, it is 1.5 zeros and 1. If it is billion, it is 1.8 zeros and 1. So when you make like billion, lots, 10 to the power, lots and lots of small cylinders, this will become very close to 1. This will become very close to 2. And that's how we get pi into 1/6 into 1 into 2, which is pi by 3. Is this clear to everyone? Anyone has any questions? Did everyone understand how by using the formula for 1 squared plus 2 squared till n squared, we can get the volume of the cone? Or someone is not clear? Who is there? Okay, Pooja Ashok. Can you unmute, please?
Yes.
Yeah. Did you understand the steps? How we divide, take the cone and divide into small things, and then which formula? What? Tell me the formula that we use. Main formula that we use for.
So 5 into 1 by n cube into 1 by 6 n plus 1 2n plus 1, sir.
Yeah. And what is that 1/6 n into n plus 1 into 2n plus 1? Why did we put that? Because that is the formula for what?
The volume of cone.
No. I'm saying when we put that 1/6 into n plus 1 into 2n plus 1. What is that? This when we put this part here. Just this part. This is the formula for.
Find out the sum of consecutive square numbers.
Exactly. This is 1 squared plus 2 squared till n squared. Okay. Did everyone understand this part? This part, how we get the volume of the cone by taking.
Yes, sir.
Yes, sir.
Yeah. Anjali, did you understand the steps?
Yes, sir.
Do you have any doubts? You can ask me anything. If something is not clear, you can ask me.
No, sir. Understood, sir.
What did we do? We took the cone and we broke it into what? Small what?
Small parts. Very small parts, sir.
What are those parts? Those parts were what shape were they? They were small what? Were they small squares or were they small something else? What were they? Small cylinders. Okay, we divide into thin cylinders, thin slices. Each of them is like a cylinder. Okay, Anjali, understood?
Yes, sir.
Okay. Okay, so this is how if you know the formula for 1 squared plus 2 squared till n squared, you can get the volume of cylinder. Okay, but I think you have not seen this formula before, right? You have not seen the derivation for why this 1 plus 1 squared plus 2 squared till n squared is this formula. Is that correct?
Yes, sir. Yes, sir.
What about this 1 plus 2 plus 3 plus till n? The formula of n consecutive numbers. Do you know that formula? Have you seen that formula before? 1 plus 2 plus 3 till n. That you have seen before, right?
Yes, sir. Yes,
Do you
sir.
know why you get the formula, or you just know the formula?
Sir, we just know the formula.
Okay,
Sir.
let's now try to understand why it is that. Okay, so far we saw volume area of triangle and volume of cone from 1 plus 2 plus till n and 1 squared plus 2 squared till n squared. We saw that volume of area of triangle is connected to which series here? Area of triangle is connected to which series here out of these two series? 1 plus 2
1
plus
plus 2 plus
2 plus
1.
2n.
Yes. And volume of cone is connected to which series here?
1 square plus 2 square plus n square, sir.
Okay, good. Now let's try to understand why we get these formulas. So we just assume this formula, right? We just assume this formula that we said that this formula, you know this thing. This is equal to n into n plus 1 by 2. Okay. And this is, we just said, we looked up online and we saw on the web that this is 1/6 into n plus 1 into 2n plus 1. Okay, but you just looked up the formulas. You don't know why it is. You don't know why it is the case. Correct? Correct? You don't know why it is this, right? You don't know how to derive this formula. Okay, let's try to derive this. Okay, let's try to derive this. Now let's do the simpler formula first. Let's do the sum of first n numbers. Okay, let's just look at this first formula. Let's try to derive it. Let's say we don't know this formula, n into n plus 1 by 2. How will you go about finding? How will you go about finding this thing? Okay, let's call it Sn. Sn is the first of the sum of the first n numbers. So S, I can't write this S. When I see the underscore, okay, I'm writing it as subscript. It's like let me just write it as a function of n. Okay, let me S of n. Okay, S of n is the sum of the first n numbers. Let's try to get a formula for S, or let me remove the n actually. Just say this S is the formula. Now we are trying to see that this is equal to n into n plus 1 by 2. Does anyone have any idea why this is n into n plus 1 by 2? How will we prove that? How will we get the formula for S? Anyone has any idea? So let me give you a hint, okay? Let me give you a hint. Think about the area of the triangle, okay? Let's go back to the geometry. We already know that this 1 plus till n is like the area of the triangle. Right? We already saw that connection. Now, remember how we know how do we get the area of the triangle? How do we know that this is half of the area of the square? How do we know that? How do we know that the area of this triangle is half the area of the square? Remember, this area of the triangle is very similar to 1 plus 2 plus 3 till n. How do we know this is half? Half of the area of the square?
By dividing it into smaller and smaller squares.
Yeah, but there we use the formula. After dividing into smaller and smaller things, we got 1 plus 2 plus 3 till n. And then we had to use the formula, n into n plus 1 divided by 2. But now pretend that you don't know the formula. So if someone doesn't tell you the formula, can you tell a simpler reason why the area of the triangle is half of the area of the square without using formula? So let's say we are not using this 1 plus 2 plus n. We are just using plain geometry, just looking at the triangle and the square. Can you tell me why the area of the triangle is half the area of the square without dividing into small parts, just by using geometry?
It is a diagonal, no?
Yeah, it's a diagonal. Yeah. So, yeah, why is the area of a triangle half the volume of area of a 1 by 1 triangle, half the volume of the square, half the area of the square, without using this 1 plus 2 plus n, don't break into small things, just by looking at the geometry? Tell me. Why is the area of a triangle half into base into height? If I have a right triangle, if this is the right triangle and this is the base is B and this is the edge, why is the area of this half into base into height?
Because
area of rectangle is base into height, sir.
base into height,
Yeah.
sir. This is.
Yeah. So why is the triangle half into base into height?
Because the area of the rectangle equal to base into height, sir.
Yeah. So okay. No, I got that. But why is area of the triangle half of that. Why is it half of that?
If we draw a diagonal, that diagonal cuts the rectangle into two equal congruent triangles.
Exactly, yes. So just because these two parts are identical, so if you take the exact yellow diagonal, then this upper triangle and the lower triangle are two identical triangles, two congruent triangles. Okay, so this triangle must be half of this. So we can use very simple geometry to tell that the area of the triangle, this if 1 by 1 triangle, is exactly half. So did we need to go to that 1 plus 2 plus 3 till n to get the area of a triangle? Or can we tell just by looking at the geometry and the congruent thing that the area of the triangle is half? Do we need to go through that 1 plus 2 plus 3 till n and take small slices and then add them up and then keep increasing n? Do we need all that to get the area of the triangle? Or we can just look at the two congruent triangles and say that the area of the triangle is half?
So looking into the congruent triangles.
Yes.
No, sir.
What we don't need? We need or we don't need? Who said no? Do we need to go through the 1 plus 2 plus 3 n, or we don't need to go through 1 plus 2 plus n? We don't need, right? We can just look at the geometry and do it.
Yes, sir.
Then tell me, Madhumita, why do you think we did this then? If we can get the area of the triangle just by using geometry, then why did we do this 1 plus 2 plus 3 till n? Do you have any idea why we did that? Why did we do this long route to get the area of the triangle? Think about why we did this and what we were doing after that. After that, we were going to volume of the cone. So note that for the area of the triangle, you actually we not have to go through all this 1 plus 2 plus n. The reason we did that was because we used that same idea to get volume of cone. And volume of cone is 1/3 pi r squared h. So if r is 1 and height is 1, it is 1/3 pi. Now in the triangle case, you can actually just look at the two congruent triangles and say it is half of that square. Can you do that same thing for the cone? Can you say that cone, there are 3 cones, so you are getting 1/3 of pi, 1/3 of pi, which is 1/3 of the volume of the cylinder. Can we say that there are 3 identical cones fitting in that one big cylinder square, the cylinder that you get from rotating the square? Sorry?
Sir.
Can someone raise the hand, whoever spoke just now? I can't make out who spoke, so can you raise your hand, please? Can we make out, in the case of area of a triangle, we can easily make out that there are these two identical triangles sitting in the square, correct? But in the case of volume of cone, can I say that there are 3 cones sitting in that one big cylinder that you obtain by rotating the square? Can I say that? Can I see 3 congruent cones? Okay, Madhumita Pujar. Can you unmute?
Yes,
please?
sir.
Yeah. So for the triangle case, did we need to actually go through this 1 plus 2 plus 3 till n to get the volume area of the triangle, or can we just easily see that there are 2 congruent triangles in the square, and so the area of the triangle is half the area of the square? Can we see it easily without using that 1 plus 2 plus 3 till n formula?
Yes, sir.
So do we need to use the sum of the first consecutive n numbers to get the area of the triangle?
Yes, sir, because we have to find volume of cone, sir, in the same way.
Yes. So the only reason we were doing it for the triangle formula is actually very easy. We don't need to do this 1 plus 2 plus 3 till n. But we were using that because that is needed for the volume of the cone. Why is that needed for the volume of the cone? Can't I just argue that there are 3 congruent cones sitting in a cylinder, and that's why it is 1/3? Can I say that, Madhumita? If I rotate this square, I will get a big cylinder, and when I rotate the steps, then I will get a cone. Why can't I just say that there are 3 congruent cones sitting in there, and so it is 1/3? Can I say that, Madhumita? Do you think we will see 3 congruent cones there? Is it easy? Can you see 3 congruent cones there? If I rotate that thing around the lower horizontal axis, Madhumita?
Sir, I don't know.
Yeah, correct. So it is not easy. You cannot easily say that actually. When you take the square and you look at the diagonal, you can see clearly that there are 2 triangles. But when you rotate it, you cannot clearly see that. Actually, it's not easy to make out that there is some 3 congruent things. In fact, there are no 3 identical cones there. But when you use this formula 1 squared plus 2 squared n squared, then you can actually get exactly 1/3 pi, where n becomes larger and larger. Okay, so that is the reason we went to this 1 plus 2 plus 3 till n, because even though we didn't need it for the area of the triangle, we needed the similar thing for the cone. But we can use this idea because the area of the triangle is easy to find by just this geometry. We can use this geometric idea to get the formula for the sum of the n consecutive numbers. So let's use the geometric idea to get the formula of the n consecutive numbers. So if I add up these 2 triangles, I'm getting area of the square, right? So let's add that 2 things like that to get this. Okay, so this is like the first n columns, right? This is like the 1 plus 2 plus 3 is like the sum of those for the n columns in the area of the triangle. So this is 1, 2, 3, like this till n. Okay. Now let's try to look at the area of the other triangle. Okay, the upper. There are 2 triangles, right? One is the lower right triangle and the upper left triangle. So the upper left triangle, the columns are n, okay, plus n minus 1, okay, plus n minus 2, plus 2 plus 1. Okay, so let me call this as P. Okay, so this is like the lower. This is like that lower triangle. This is the number of the area of that first column. This is second column, third column. Okay, and then let's look at the upper triangle. So these triangles. Okay, the first column here in the lower triangle has 1, and then second column is 2, 3, 4, like that, like that. And this is like this is decreasing the other way. This is n minus 1, n minus 2, like that, like that. Okay, so I can use this idea similar idea to get that sum. So let me go back to the sum. Okay, so in the in the lower triangle, the numbers are increasing, and in the upper triangle, the numbers are decreasing. So let me just take it in the reverse order. So I just take this 1 plus 2 plus n, and I do it in the reverse order. N plus n minus 1 plus n minus 2, and so on and so forth. And now think about why these 2 things together become like a square, almost like a square. This S and T, are these S and T same or different? So the first sum is 1 plus 2 plus 3 till n. Think of it as 1 plus 2 plus till 100. The second one is 100 plus 100 minus plus 99 plus this. Okay, let me actually write it for n equal to for 100. Okay, so for n equal to 100, it is 100 plus 99 plus 8. Oh, sorry, I reversed it. One, 1 I think you have to go, right? You have the other meeting. Just think about, this is like the lower triangle, this is like the upper triangle. So I just took these numbers 1 plus 2 till 100 and I just took this in reverse order. But I think you have to go to the other meeting. Is that right? You have some mentor meeting right now, or you don't have it today?
So we don't have today.
30.
Oh, you don't have today. Okay. So let's continue for a little bit.
So on 11:30. So we have now
You have
only.
meeting? You have meeting now?
Okay, I now.
Yes, sir.
You have now? Okay.
Sir.
Okay, let's continue next time then.
Okay, sir.
Okay, thank you.
Okay,
Bye.
sir.
Bye, sir. Thank you, sir.
Bye,
Bye,
sir.
sir. Bye, sir.
Bye bye.
Sir, bye, sir.
Bye bye.